Hello everyone. In this lecture, we're going to discuss a form of nonlinear pricing called two-part tariffs. Before we start, let me ask you a pricing puzzle. Why doesn't your mobile service provider charge you a data plan by megabytes? I think nowadays almost all of us get our mobile data plan in packages. We use 2 gigabytes of data. We pay $30. If we use 4 gigabytes, we pay 60, etc., etc. Why doesn't your mobile service provider charge you by the data you actually use? Pause the video and write down your answers. Okay, instead of revealing the answer to this question, let's go through today's lecture and find out. What is a two-part tariff? A two-part tariff requires a consumer to pay two different separate fees. There is a fixed fee that is associated with the right to purchase the product, but not the purchasing activity itself. It's kind of like a membership. It's not associated with the quantity of consumption. And then after paying the fixed fee, the consumer can purchase as many units of the products as desired at a specific per unit price. So that's the variable fee. So we have big F, the fixed fee, small f, the variable fee. And then the consumer's total spending would be the fixed fee plus the variable fee times the quantity purchased. Here's an illustration of a two-part tariff. On the horizontal axis, we have quantity. On the vertical axis, it's the total cost to customer. Here is a linear price. This is the most common price we see. We go to Amazon, we buy one pencil, it's 50 cents. We buy two, it's $1. We buy three, it's $1.50. The total cost to customer grows linearly with quantity. So what two-part tariff is, it does not start from the 0 point, but instead, a two-part tariff plan would start from a certain level of fixed cost to the customers without having to purchase anything, which is why this line intersects with the total cost, not at 0, but with certain values. So this is where the fixed fee is, and how steep this line goes, that's how much the variable fee, small f, is. Today we cover 3 different things under the topic of two-part tariffs. First, if there is only one segment of customers that we want to sell to, and we offer an optimal data plan to this segment, what that pricing plan would be. Second is, if we offer one pricing plan, two-part tariff, to 2 different customer segments, what that pricing plan looks like. And the third is, if we can offer 2 different two-part tariffs and allow each customer segment to choose whichever one they prefer more, what are the 2 optimal two-part tariffs? The example we give is in the context of a wireless data service. Let's say in this market, there are 2 types of users. One segment are the high-value users who use a lot of data. They value data more. And then there are low-value users. They do not use a lot of data, so they value the data less. Further, let me show you the demand of each customer segment. In this curve, the horizontal axis is the data charge, which is the small f. The vertical axis is the data demand. Here, we assume all the customers in each segment share the same demand curve. So For the low value segment, we define the demand curve as follows. The quantity, small q, is equal to 10 minus the variable fee, small f. What this says is when you charge 0 variable fee, then small q equals 10 minus 0 is 10. So when you don't charge usage, this segment of consumer would use 10 gigabytes of data per month. And the number of customers in this segment is N1. The second line is the demand for the high value segment. The high value segment customers have a demand curve of Q equals 12 minus F. They value data usage a little bit more. They use more data. When the small f is 0, when you don't charge them for data usage, Q is equal to 12. So they use a little bit more data. And the number of customers in the high value segment is N2. So these are the two demand curves we're looking at. For the low value segment customer, if you charge $10 per gigabyte, their usage Q equals 10 minus F would become 0. That is, if you charge $10 per gigabyte, the low value segment would drop out of the market. At $10, the high value segment would use 2 gigabytes of data. So each customer within the segment has the same demand curve. First, we consider the scenario of serving low value segments only. This is the demand for the low value segment, assuming 0 variable cost. Option 1 is, what if we charge on a per gigabyte fee basis only? So it's basically linear pricing. Big F is 0. What is the optimal small f? And here, when we charge a small f, the demand is 10 minus f, and the profit for the company is small f times 10 minus small f, basically the size of this small square. So profit equals f times 10 minus f. The optimal price f would fall between the variable cost 0 and the endpoint of the demand curve 10. So the optimal small f in this case is 5. And at $5 per gigabytes, the demand is 5 gigabytes, and the profit per person is $25. Now, what about this orange triangle? As we have discussed, we usually call this money left on the table. So which means customers in this segment are actually willing to pay more for the first 5 gigabytes of data in the beginning, and then gradually this willingness to pay drops. So this orange triangle is the consumer surplus from being able to pay only $5 per gigabyte. And the total low value segment surplus is the size of this triangle, that is half times 10 minus f, and times the height is again 10 minus f. And that is equal to $12.50. So that's the low value segment surplus. Now, the second option, again, serving low value segment only. Again, assume 0 variable cost. So what about if we charge only a flat fee instead of the per gigabyte cost? So we force small f to be equal to 0. Because there's no data charge, Q equals 10 based on the demand curve. And then we charge $50. The profit from each person is basically the big F, $50. That is, we use the pricing scheme to capture the whole triangle. 10 times 10 divided by half the size of this triangle. Now, what about serving high value segment only? Again, assuming 0 cost. Option 1 is to set a per gigabyte fee only, forcing big F to be 0, and small f is what we are trying to find out. Here, the profit is the size of the blue square. So profit equals to small f times 12 minus small f. The optimal small f, in this case, falls between 0 and 12. It's $6. And at $6, the demand is 6. So the profit per person is the high value segment surplus. And the size of this triangle is equal to half times the width of the triangle, 12 minus f, and the height of the triangle turns out to be 12 minus f as well. So the high value segment surplus is $18. Of course, a second option for serving high value segment is to charge a flat rate by forcing small f to be 0 so that the demand is 12. So people are using all the data they need because there's no charge on the usage fee. And then charge a big F, charge a flat fee of $72 because the data plan itself in total is worth $72 for the customers. In this case, the profit per person is $72 from the fixed fee. And it again captures all the surplus in the blue triangle. That is equal to the width of the triangle times the height of the triangle and divided by 2. So the key lessons so far, if we choose to serve only one of the two segments in the market, if consumers are similar in their usage intensity in a single segment, we're assuming everybody in the same segment to be the same, actually. So the optimal pricing strategy involves setting a usage-based fee that is equal to marginal cost, in this case, 0. And the fixed fee would be equal to the consumer surplus from the specific segment served. So in this case, the two-part tariff enabled the firm to extract all the possible surplus. The only downside is the company has to pick one of the two segments because if you charge a fixed fee of $50, then the high value segment customers are going to buy the $50 plan as well. If, on the other hand, you charge a fixed fee of $72, then the low value segment would drop out of the market. So, with only one pricing plan, the companies have to make a choice here. Next, we discuss how to use a single two-part tariff to serve both segments. Previously, we have either constrained the usage fee small f to be 0 or the fixed fee big F to be 0. But here, we allow both big F and small f to change around, and we're going to find out what the optimal two-part tariff is. With a single two-part tariff, if we charge a small f data usage, then the low value segment would have a demand of 10 minus f, and the high value segment would have a demand of 12 minus f. And the profit from the two segments based on the single two-part tariff is equal to N1, the size of the low value segment, times this part is the revenue from each one of the customers. And part of the revenue would be from the fixed fee it charges, and a part of the revenue would be from the variable fee, that is, the usage-based fee times the total data usage. Similarly, we have the second component, that is the size of the high-value segment times the fee they can receive from each one of the high-value customers. It includes a fixed fee and the variable fee times the data demand. Now let me recap quickly on the three options that we have discussed so far. For simplicity, we assume the two segments are both of size 100. So for option 1, we use the single two-part tariff for the low value segment, with a fixed fee of $50 and a variable fee of 0. In this case, the demand for the low value segment is 10 and the demand for the high value segment is 12 because the high value segment would happily buy the plan with a fixed fee of $50. Now you can serve both segments with a total profit of 200. That is the size of the two segments times the fixed fee of $50. So the total profit is $10,000. The second option is to use the single two-part tariff we developed for the high-value segment, where we use a fixed fee of $72 and a variable fee of 0. Here, the low-value segment actually drops out of the market because this fixed fee is too high for them. They are only willing to pay $50 max. Now you're charging $72. You can only serve the high-value segment with this pricing plan. And the total profit is 100, the size of the high value segment, times 72. That's $7,200. Option 3 is to use a single optimal two-part tariff that serves both customer segments. In order to optimize the two-part tariff plan, we need to take the following steps. Step 1 is we know the usage-based fee has to vary between 0 and 10 because when small f is above 10, the demand from the low-value segment goes to 0. We vary small f between 0 to 10. And the second step is we set big F so that you can extract all the surplus from the low-value segment. Remember, when you charge a small f in this chart, and then you're going to have the surplus that the low-value segment is going to receive here. So we use a fixed fee to extract that whole triangle. So the size of that triangle is half times 10 minus f, the width of the triangle, and 10 minus f, in this case, the height of the triangle. When small f is equal to 0, the baseline scenario, the big F is 50, that is the whole triangle, and the profit is 1,000, and the profit is $10,000. So this is the scenario we have discussed earlier. But when you start to increase the small f, so you change small f from 0 to 1, and in this case, the big F, based on the formula here, it varies to 40.5 because the consumer surplus is no longer 50. Now you have charged data usage fee. And in this case, the profit is $10,000 and 100. And the design here is the low value segment no longer has surplus, but the high value segment will still have certain surplus. It turns out small f equals 1, big F equals 40.5, and the total profit equals $10,000 and 100 is the optimal price when we design a single two-part tariff to serve both segments. Recall that in the previous scenario, the most profit we can get between options 1 and 2 is $10,000. So option 3 is better than either option 1 or option 2. Here's the profit formula. And the high value segment surplus is half times, remember that triangle formula for the high value segments, and then deduct the fixed fee that we charge in this two-part tariff plan. So the key takeaway so far is if we are using multiple segments with different usage intensities, the optimal pricing strategy involves setting a usage-based fee higher than the marginal cost. So instead of small f equals 0, the optimal two-part tariff is actually small f equals 1. And the fixed fee in this case is equal to the consumer surplus of the low value segment. The final pricing plan is to design an optimal manual two-part tariffs. In this example, we have two segments of customers, high value and low value, and we are going to design two different two-part tariffs, one for each segment. So what I'm talking about is we are going to design a high value plan, F big H fixed fee and small f big H variable fee for the high value segment. And then we are going to design a low value plan, big FL and small fl for the low value segment. The problem we need to address is high value segment might find the low value plan attractive because it's cheaper. If their surplus from the low value plan is higher, then they are not going to choose the high value plan. In order to prevent this switching, we need to address the incentive compatible constraint. That is, we need to price to prevent the high value segment from choosing the two-part tariff plan designed for the low value segment. Design pricing to ensure high value segment users like their high value plan more than the low value plan. How do we do that then? To design a manual two-part tariff, it involves charging a high fixed fee and a low usage fee for the high value segment, and a low fixed fee, high usage fee for the low value segment. This scenario maps very well into the real life experience we have. When you want to use a usage-based fee for data plans, they tend to be very, very expensive. So we must ensure, again, high-value users will not want to choose the tariff plan meant for low-value users. So to achieve this, we need to follow the following steps. Again, we start with varying small f for low value from 0 to 10. And step 2, we are going to extract all the surpluses from the low value segment, just like what we have done in the previous case. For the high value plan, we are going to set the small f usage-based fee at the marginal cost, in this case 0. And then we set the big F, the fixed fee, at such value that the high value segment customer would have higher surplus from choosing the high value plan over the corresponding low value plan. So the formula here is to use 72 minus the surplus from the high value customer choosing the low value plan. For example, let's look at the first case. We set the small f for low value plan to be 0 and charge a fixed fee of $50. So the low value segment would have a 0 surplus, as we have discussed before. And the high value segment, when they choose this plan, they would receive a surplus of $22. If you remember, the total size of the high value segment triangle is 72, so they would have $22 surplus. Now, when we design the high value plan here, what we need to ensure is the high value customer would have at least as much surplus here comparing to here. So in the first case, the high value and the low value plan actually converge. They are the same. And then the total profit, as we have discussed before, is $10,000. So similarly, we calculate each row of the pricing condition. And in this plan, the optimal case is to, as highlighted here in red, is to charge a low value fee of $2 and low value fixed fee of $32, and then for the high value plan we charge 0 usage fee and $54 fixed fee. The high value segment would receive the same surplus from either one of the plans at $18, and the total profit is $10,200. So here is a summary of the optimal manual two-part tariffs we have just designed. The total profits in this case is $10,200 as compared to $10,000 from option 1 and $7,200 from option 2 and $10,100 from option 3, that is a single two-part tariff plan. This plan gives the company the highest profit. To quickly recap, the goal of nonlinear pricing, like a two-part tariff, is to reduce the passed-up profit, encouraging customers to buy more. And second, although a more complicated pricing plan can extract a high profit, they are also more difficult to implement. And third, as we have discussed extensively earlier, the optimal pricing plan has to allow consumers to choose freely and prevent high-value customers from switching to lower-priced, low-value plans. That's our discussion for two-part tariffs. Thank you. I'll see you next time.